Okay, everybody can hear me, right? So Ariel already introduced me. This is me. What I'm going to talk about is basically the main goal of it is to shed light of the features and what are the best practices for security in Kubernetes and what features Kubernetes provides to do that. So if you look at your regular pipeline and how containers change that, this is how it looks like. You have build on your left and runtime on your right, and the security need to be in line with that. So we'll go from the left to the right and see what we think needs to be done. You need to make sure that only what you want and what you authorize to run will run in your environment. You need to make sure that the images you run pass your security assessments and vulnerability scanning. And as just I said earlier, you want to integrate security into your processes, meaning your CI/CD pipeline. Let's see what it means. You want only vetted code go into production and to the build, meaning basically you need to take your source control and integrate it into the build process so that only what pushed and approved and went through all the code review and etc. processes goes on. You want to implement your security vulnerability scanning for vulnerabilities. You need to do it not just once, then you build it. You need to do it repeatedly because vulnerabilities are introduced every day, and what you already thought was secure yesterday may not be secure tomorrow. You need to apply once you find those vulnerabilities, you must be able to quickly and automatically update your images and redeploy them into your production. You want to use private registries as opposed to the public registries, and to minimize the use of public images where as possible. Because public images are less secure by definition. You're less aware of how it's built and what it contains. Now let's step further. What you need to do about your environment to be secure. You don't want to allow SSH access to your hosts or to your containers because this opens your hosts to potential attacks, and you want to minimize the threat. I lost the word. Your threatscape of your hosts. You want to use kubectl exec if you need to execute commands on your containers and get what you need. Kubernetes have a feature called authorized plugins, which basically enables you to apply fine-grained controlled access control on your namespace, containers, etc. Where several modes for that: attributes-based, role-based, webhook module, which you can basically connect it to the outside authorizer, and you can write your own custom model. We'll see a small example of what it means a little later. You want to create administrative boundaries between your resources so that to limit the scope of user permissions to only the part of your environment which they require. Kubernetes namespaces are facilitated basically just that. And once again, the Kubernetes authorization plugins enable you to connect and apply policies connected to your namespaces. Let's see how this looks like. This, for example, an example of policy which applied to namespace fronter, which, like, let's say your front end, and it says that Alice only allowed to read pods at this namespace. She won't be able to do anything else. You want to limit the number of containers and pods which runs unbound, resource unbound, because this is risky in a shared environment itself and in a cluster. If you have a noisy neighbor, or it may pose an additional threat. By default, Kubernetes, if you don't do anything special, all containers are created unbounded. You can apply resource quota to pods, CPU resources, memory resources, and it's assigned per namespace. This is an example. You configure your policy, which in this case says that the pods are limited to this namespace, computer resource, to 4 pods, 1 CPU, 1 to 2 CPUs, 1 to 2 giga memory, and hard means Kubernetes will enforce that. And then you create namespace with that policy applied. One of the things which is painful and problematic is how you manage your secrets, let's say your passwords, your AWS token, your Google tokens, and you don't want to do it, to have it inside your container. This is a very bad idea. And you want to manage it centrally and preferably securely. Kubernetes provides a feature for that, which we'll in a sec see its pros and cons. But you can create secrets, and then it will be distributed to the pods and containers you want. So how it's distributed, it can be either mounted to your containers as a file or as an environment variable. But the implementation right now has certain risks applied to that. First of all, secrets itself stored in etcd backend and stored in clear text. It's persisted to disk also in clear text, which is a bit of a problem if you have compliance issues or requirements. There is no real separation of duties or true permission effects. Any operator can see secret value, even if it's the operator, I mean the one who runs the container. It's may not necessarily capable of retrieving the secrets, but it can always run another container and receive the secrets that way. And another thing is that containers are available to the node even if this node does not need this secret, meaning no pods or containers are running after that. This is an example how you create secrets. You basically create either automatically using kubectl. You write it to the files, and then you, from those files, create objects, resource objects inside Kubernetes that are secrets. And then you can query these secrets or see how they look like. Or you can do it also manually. And you can see it basically here. It's base 64. It's get pushed from the YAML file. Feel free to ask questions, by the way. Networking. If you have container in your environment, which got compromised somehow, if your network is not segregated, meaning there's no limitation applied, it basically opens the door to the whole container because the network is practically flat. So you need to segment and segregate your cluster and clusters in a way where each container has only access to what it's supposed, to whom it's supposed to talk with. Cross-cluster segmentation is relatively simple because you can apply usual controls like a firewall, but containers are very dynamic. They come and go at rapid rates, and applying regular network controls is practically impossible. Kubernetes has a work going around this to allow pod-to-pod network segregation. Right now, only the ingress policy is implemented, and it's also in a beta stage. This is how such policy would look like. I hope you can see it. You can, again, this is enabled by annotating the namespace, saying in this namespace, the policy, network policy is allowed. And for example, in this case, the default is default denied, meaning anything which is not allowed will be denied. And this is an example of the policy. Can you see it? Cool. It basically says that the namespace default, any pod which have a label role with value db, we allows to connect only from namespace which has a label project my project, and only from pods which are matched to the front end label, meaning only front end pod from the my project namespace will be allowed to connect, and only to the port 6379. Yes.
Are you pen testing this before? Penetration testing, did you do that? First and second, which encryption technology?
You the question was, did you pen tested it? And the second is it encryption? One thing which need to be said about network policies is that Kubernetes provides the policy engine, but the implementation is a backend which needs to be provided by with Calico or whatever, and it's dependent on that basically. Okay. I actually go too fast. Let's talk about runtime. The security usual mantra is you need to have least privileges on everything, on your runtime, on your network, whatever. Everything needs to be least privileged. What does it mean? It means that the process and the user, and from the network perspective, what you run needs to be able to do only what it has to do, nothing more. If I don't need to run as root, I should not run as root. If I don't need to talk to somebody over network, I should not be able to do it. If I don't need to be able to execute files, I should not be able to execute them. Container provides an opportunity to do that because container is very limited functionality by design. So implementing least privileges should be conceptually easier. Kubernetes provides what it calls security context, which is basically a property defined which enables to control the security parameters that will be applied to the pods and to the containers, which will be later run. We'll see in a sec what kind of properties you can apply. There's also something called pod security policy, which is also somewhat in a beta. Some of those features, by the way, which we talked today, are in a beta stage, meaning they're still getting developed and phased to the position where we'll be much more mature because the needs are still being figured out. Pod security policy is basically a policy which defines what are parameters which eventually need to be on the containers and the pods for them to be run. And if those pods, after applying security context and parameters which they run with do not comply to that, the pod will be denied running. Additional to that, there is something called admission controllers, which is somewhat also plugins. Some of those you need and have to enable for some of the Kubernetes other features. In this context, I will mention 3 of those. Deny escalation exec. If you enable this, it basically means that you will not be able to exec into the container if it's running with elevated privileges. Image policy webhook, we will expand it a little bit later, but it enables to, if we talked earlier about scanning the images and during your build and test stage, you want to make sure that during the run stage, those images will still not be able to run. Image policy webhook enables us that. It enables to add an external image reviewer to the images which are about to be run in the runtime. All the spool images is useful in a multi-tenant cluster because basically enforces that every time the container to be run, the image will be repulled, which means if you already have it cached on the host, it will not be able to use unless the user who is going to run this container has the rights to pull it from your registry. And those are the features, main features which you can apply to a security context. There's more, obviously. You can say that container cannot run as non-root user. You can apply capabilities you want to have the container to run. You can say that your root file system must be read-only. And you can, the first 3 are somewhat container context. And the final one is a pod context. It says that it's somewhat similar to the first one, but it's on a pod level, saying any of the containers inside cannot run with root user. This is an example of the security context. It's pretty self-explanatory. You create a YAML file as usual, and you specify parameters as you see fit to your environment. Image policy webhook. It's basically just like I said. It enables to connect before the images gets run. It enables you to send a request to external reviewer for an approval. This is an object image review, which basically has the fields which describe the container being admitted, about to be run, as well as any pod notation of this type. This basically enables you to create additional information on top of that, which is pure execution. We'll see in a second what it means. This is an example of such a webhook object which to be sent for the approver. It has a tag, the image name, the image digest, and the annotation. In this case, for example, annotation says break glass. Basically, it means I want to create an exclusion or exception for this specific run, even if its image is not supposed to be run because, I don't know, it has critical vulnerabilities, but I must have it in my runtime. This, obviously the reviewer implementation supports that. This label will be sent also to the reviewer, and this reviewer will return, okay, you can run it. Okay? Monitoring visibility. One of the things which security is well as far as everything goes well, but you must log everything which happens to be able to both see and know later what's went wrong. Nevertheless, Kubernetes enables cluster Right. Cluster-based logging basically enables you to redirect all of your containers standard input, standard output, standard error to the central location through FluentD agent, and later you can ingest it by those, but by your tool, by your choice of tools. So, what did we see? Let's summarize it. We described the whole pipeline from the left to the right, and we saw what kind of tools Kubernetes provide you in order to enable to create secure environment. One thing which is noticeable is that Kubernetes misses the runtime, what I mentioned earlier, for example, making sure that only what's supposed to be run is run within the container. This is something Kubernetes does not provide today. If you want to know what we can do on top of that, you can talk to me in the break. And I went a little bit too fast, so if you have questions. Thank you.
Questions? Misha?
Actually, one question. I didn't hear you talk much about namespaces, networking namespaces, and work related to like Calico or things like that. Is that in the radar, or are you just?
No, I mentioned it.
Oh, sorry.
It's okay, no, it's fine. I mentioned it in two, actually, contexts. First of all, the network policy is applied to the network, to the namespaces. And the now one is that the network policy is only a vehicle, meaning you define the policy for Kubernetes, but the implementation of the network policy is you have to have the backend. I mean, if you don't have it, it just won't work. It just will be there in API server, but it won't do nothing. So if you have Calico on your environment, it will enforce it. Yes, please.
Hello. In the first part where you're doing the build and you're scanning the container, can you recommend tools that you would use to scan the container for vulnerabilities? I know like Docker Hub does it automatically, but if you're not using Docker Hub, like what tools can you use to scan your containers?
I can. Talk to me in the break. I will recommend you one.
Yeah.
Go ahead, you could say it.
Yes, we do it.
Yeah.
We are the leaders of doing that.
Oh.
For real. Yes.
Hold on.
Do you guys offer any connectivity for IPA servers or anything?
Do you guys offer any connectivity for like an authentication server with users management, or is it just you have to create the user in the?
We do.
And what do you support?
Active Directory, LDAP. More questions?
All right. Thank you very much, Misha.